performance high. That's what we do. Then if your supervisor not reads, then you have to do you have to look for optimization. So we're not to use deep learning. Then using deep learning is good, but it's sexy. Everybody likes deep learning. The paper, oh my one is deep learning for something, and everything is going to be deep learning. Even if you increase the number of layers, that's going to be deep learning for everybody, which is not the case. So take a message. If you really want to look for a simple problem, better not use deep learning, because you're not looking for a problem. You're looking for parameter tuning, and hyperparameters are more than the size of the input data. Basically, you're not tracing. Basically, you're tracing input data by working on hyperparameters. That's not good. If you drink coffee, you're not going to use shovel. If you are going to use a spoon, that is conventional machine learning, it's going to work perfectly fine. If you have to clean the driveway in the snowfall like us here, you basically want to take shovel to clean snow in your driveway, spoon for the coffee, shovel for cleaning driveway. It is important to know that it is nice to use deep learning, but come on, why do you make things complicated? Let's not make things complicated. So talking about COVID-19, I'll give you an idea. If we had, imagine if we had cross-population tools in place, we would not have felt that hard time in Italy immediately after Wuhan COVID-19 began, because we could have trained a model there and test in Italy, which was not the case. And we also don't care multimodality and multitudinal data in place during our research studies for a long time, because we look after winning by counting number of papers, and we're so happy with that. At the same time, why not we look after active learning, meaning if my machine is going to learn in accordance with the experts, when they expert. Do you see these doctors, they see COVID-19 before? No, they see COVID-19 exactly in December 19. Jan, they see more COVID-19 cases. To March 20, they see more. My machine is going to work with them. Why not we let our machine work with the doctors and get trained over time? Having different data, we call multimodal data, so that my machine is ready for testing cases in Italy. That's what I want to do. That is the last term, but we didn't do it because we just make people fool. We never convince healthcare experts, and things not in place, because we just need publication, not make sense. So while talking about COVID-19, the COVID-19 hits hard. I have a friend from India. You probably know these people. We look after mortality and recovery rates because we don't really understand the way how WHO conventionally compute these mortality and recovery rates. They do count even those people who contracted today in denominator, number of dates divided by how many contracted. You cannot count the people who is just got contracted today and put in denominator. You can't do that. You think they're going to die? This is brutal. That's why they are wrong. Technically, they are wrong. Mathematically, they are wrong. But when you see, that's why we revisit the mortality and recovery rates computation. We miss recovery time period. We can only count you after 14 days, because until 5 to 14 days, that's a 14 days average recovery time period, we cannot count and we cannot think them they are going to die. We should not do that, because they are not going to die. If not, they are not the death rate. There should be recovery rates, and they forget that part, because I don't know they don't care about public or not, but this is not right. While talking about this, we take care of multiple cases. One is the real world problem. Other one is a two-way problem. We imagine 200 people in one village and starting infecting them. That's a two-way problem. So in the very beginning, their mortality rate is here. Our mortality rate, their mortality rate is here, the blue line, and our one is progressive because the COVID-19 is not done 8. We say progressive because it goes over time. The funny thing is They look right, but they are not right at the end, because once every people in the village got infected, their numbers and numbers gonna intersect, meet at the same time, at the same place, at the same location. That means even though they did mistake during the progression, it doesn't look like they did mistake. But at the end, when things are done, we made the exact same point. That's why people don't really see that it mistake. We figure out it is not the mortality rate, it is a progressive mortality rate, by the way. That's what it should count. We look after next generation education, not about phishing and manipulating data, by the way. So let's not talk about it. This is what it is. And at the same time, I like I say, why not cross-population tools and place? Why not active learning? Why not multimodal data? I published this one some time ago. Probably this one I took the screenshot sometime to August 06, 2020. Probably citations keep increasing. Probably, I don't know. But while talking about these, if we have data over time, like I said, the data for COVID-19, you don't get data, and you cannot wait data for 2 years. That's my plan. Do you want to wait data for 2 years and make a system? That makes sense. Then what do you have to do? You have to look after active learning. Active learning will help your system learn over time, like these clinical experts, they do. Like you said before, clinical experts, they don't see these problems before. They learn over time. And they say, we call them experts, but they do nothing. I don't know. They do a good job. I don't know, but come on, this is Oompa Loompa. Why not our system learn exactly in the same way that people learn? We understand that AI is going to work. We understand that learning is going to happen over time. Then why not we let people, why not we let machine learn with respect, with the help of the experts on the table? If we do so, we will not have this problem. Again, we don't really make our healthcare experts convinced to our products and the tools and technologies ready for them. We are so bad not making convince to those people and state government and so on. That's why we don't have our system in place. So when you see kind of manifestations of COVID-19, the chest X-ray should tell a similar story about COVID-19 with respect to chest CT scan. So why not we take both into account and make decisions? We should not make decisions when they're telling a different story, but there must be a consistency telling. So consistency storytelling from both modalities. So the both must be taken into account. That's what we said. We tried truncated inception rate for COVID-19 detection some time ago. We tried that one, meaning we try to make it smaller and smaller. I have money, doesn't mean that I'm going to buy a high performance computing machine for my student. I want him. He engineers something. That's what I want. So he's coming up with the lightweight, this one, which is basically really small like this. And we published the paper with the help of this COVID-19 data. 19 data with pneumonia, tuberculosis, and healthy ones like that. And we have 6 different data sites coming into play. And this data and deep features, everybody knows, because deep features Oompa Loompa for me, but I don't have to talk about this. And when you see the results, sometimes we get 100%. Sometimes we get 100% here. That's not nice. I don't really expect now 100% results. There must be something wrong or biased or something. This one. So, but again, we try to see things over and over. We try things over and over, but we get the results, which is basically a silver lining in terms of sensitivity and its specificity. And we got the standard deviations like very close to 0, which is a good idea. And we see this ROC curve and so on. While talking about all these things, since March, February, people start doing this chest X-ray imaging stuff for COVID-19 detection. They start with 25 images. They start with 68 images. They start with 50 images, 162 images, that's us, and the 200. And today we got, last December, we've got like this 50,000 image data in place. But again, the results is again 96%, 92%, 94%, and so on in terms of accurate area under the curve. That means we basically don't know. In terms of COVID-19 imaging tools in 2020, can you tell me how big data is big? Basically, nobody knows. They still want big data, but I'm going to tell you a story based on my experience is this. How big is basically a nice term. but we don't define a way. Big data does not guarantee you giving you extra or additional manifestation, a possible manifestation about COVID-19. It will give you some extra or additional manifestations, possible manifestations, but it will not give you additional. It doesn't guarantee that. But it doesn't mean that we don't increase data. We still have to increase data, but it doesn't guarantee. That's why even we got 50,000 data, as long as we don't have additional manifestation, it doesn't go anywhere. That's why how big is big, how big data is big, basically is not well defined in terms of COVID-19, because we're not making things on the ground. Talking about multimodal data, one of my collaborators, again, this collaborator is Coach Roy, Professor Roy. We've been talking about this one. We published this paper some time ago. And while talking about this, we got two X-ray CT scans. We try to use one architecture for both data sites. And this was the data. This was the data we took some time ago, many months ago. But again, it works perfectly fine. We don't have to tune the same architecture for both different modality. One architecture is going to work. That means there are some possibilities that we can get similar manifestations, similar characteristics about particular event, which is COVID-19, even from both image data. That makes us more stronger in terms of decision making. So this work is with Professor Ray, Himadri, and many more. We got a nice name there, by the way. So I'm done with all these things, but I'll give you something cool here because this is kind of break for me all the time, but I'll give you some extra activities at USD Computer Science. Just be with me. I don't know, this is the same one. If it's the same one, I'll move, otherwise. This one doesn't look nice, but let's see, this one is going to be okay. I don't know which one is the one. Look at the move. So let's see. I don't know. Is the same one? Probably the same one. Okay. Let's move on here. I'm doing so many other things, by the way, so I try to make you guys happier than, because talking 2 months and no videos, nothing is not a good idea. Some things coming up, and we've got one book coming up, which is our third book, Deep Learning for Medical Imaging in Elsevier. It's going to come up. So basically, profession is good to take into account, but again, your health is very important, which is COVID-19. And when COVID-19 hits the globe, you basically would like to stay home because you want to live your life with your family. If you really want that, start running today and have your health first. You do not want to compete with anybody in the department. You do not want to say that this guy is doing good, I'm not doing good. Come on, if you do your health right, that's your competitors. Your competitor is your health, because the day you born, you happen to have so many dust particles, you happen to eat so many foods, that unwanted foods you basically don't want, but happens. Basically what it says is your health is very important. So start running things. I do run all time in my life, so I feel like I'm getting extra life, and it's important. It's very important. You're not going to compete with your colleagues, you're not going to compete with your friends. Do network, make a very nice work, because as long as your health is good, you're good. Nobody can compete with you. One work a day, one idea a day is gonna be 365 ideas a day, sorry, year. That makes a lot of sense. You don't have to compete with anybody. Any questions? These are my two kids. Really play with my kids. My family is important than profession. If as long as my health is right, I'm good with my family, profession's gonna come into play. You don't have to die for promotion. You don't have to die for your job. Job comes only after your health is right. If your health is not right, you look after finding an opportunity to go for home and stay home and asking for a holiday. Your boss is not going to get you. One day is good, second day is good, because health is not right next day. Don't look after job. Job is gonna look after you. Otherwise, fine. This is my take home message. Thank you very much. Questions? I'm on time, by the way. It's kind of 1 hour. Thank you.
Yes, thank you, Dr. Casey, for your nice talk. So, is there any questions for the audience? If we can, a few, one or two questions. Any questions, audience?
Hello.
Yes, please.
So from the image, you can understand the severity of the COVID you have mentioned, right?
I think the problem of working in medical imaging is annotations, and people blame doctors don't do annotations for us. It's because they don't believe us and they don't want to. And
Yes.
we never convinced in our lifetime the doctors, look, we can help you. We never convinced. That's why the help from the clinical sides never come into play. It is possible when you see the behavioral work of other pulmonary abnormalities, let's say tuberculosis, we can see severity, because in our tuberculosis case, we have annotated version of the data that tells us how severe the data is. From, we say, uh, tuberculosis 2%, tuberculosis 16%, tuberculosis 90% chances, and so on. If we have that data, we convince people and we convince our clinical experts do something for us and help the society. It is possible to do it.
So my question is that, is there any automated software is available that mention that, okay, it is 30% affected or 37% affected, that much resolution?
So, like I said, in tuberculosis, we have data. We did that at National Library of Medicine. But
Okay.
since we don't convince clinical experts into COVID-19, we have no time to convince. We stay home because we look after our kids, our family. We stay home. We blame institution. I'm not gonna come. I'm gonna die. Come on, you want me to? Right? We
Yes.
don't really convince. Somebody has to work, and we work. I don't blame people too. We really work, but as long as, like I said, based on our tuberculosis experience, as long as data are annotated properly by clinical experts, how am I going to get annotations from clinical experts? That means we have to make them convinced that we will come out with something to serve the society, not to look after my promotion and look after somebody's ass to kick. If I'm looking after somebody else to kick, oh, I published 2 papers, I'm gonna kick his ass, it's not gonna be convincing for a clinical expert, and we don't get annotation data. That means we will not have chance to work. Otherwise, it's possible, yes, why not?
Thank you. Thank you, guys.
So I have one question. So what will be your suggestion for budding researchers? As you were saying, you are applying deep learning and also other schemes for the COVID. So those who are starting their research, should they start, as deep learning is a buzzword right now? So the budding researchers, should they start deep learning from the very beginning, or they should start from the basic handcrafted features and move to deep learning in the later stages of their research?
What I really want, how many of us student and PhD scholars, how many of us here? Probably many.
There are lots of students are there, PhD scholars.
Okay, so
There are a number of there.
You know, Casey, I can give you statistics. There are 70 plus participants in your talk, and 50 plus is PhD student, MTech or PhD, MTech to PhD.
so
Yeah.
for these early career research scientists,
Yeah.
let me tell you something. You basically have to know how neural networks work, not about just having Keras or TensorFlow and then you do something else and you amaze your supervisor. End of the day, you do nothing. Basically, you cannot explain things. That's what we call deep learning, is just a box. You have so many, back in days when I started my coding, I code even a small piece, how to find the distance between 2 points, I have to code by myself. These days, everything comes into play. Everything is in boxes, is put in, that's the garage boy. By the way, so I want them understand what the artificial neural network is. I want them understand what makes a artificial neural network, ANN, a deep learning network. What makes, who can tell me? Because I increased the number of layers. We did that, by the way, in 60s too. Somebody has to tell me, and they have to understand what makes this network is a deep neural network now. You have to know this one because you need to get the job right. You need to do something right. At the same time, you will have to understand the neurons working in there, not just putting so many numbers and tuning the parameter. Like I said, if your input data is too small, basically you're working on the parameters, not on the data, to get the results at the end. You have your data is 200 and your parameter is to 2000. Parameters numbers 2000. Let's say, what do you work? You work on basically a parameters, not on the data. It should be opposite. And at the same time, if you can do exact same thing with your neural network or a conventional machine learning things, you don't want to go with deep learning neural network because you want to be sexy. You can't do that. That means you understand nothing. Please understand the sentiments of computer vision scientists. Please understand the working behavior underneath. Not just use it. I can tell you, if I stay today for just to work and I have so many tools apply, I can get 5-10 papers a day. But did I learn? Did I give something to the society? I give numbers. 92%. So what? I feel like I'm going to grab his neck and then put him in the water right away for 2 minutes. I feel like that. But no, you basically have to learn in a way that you serve the society. That means you don't want to go directly to deep learning because you don't know ANN. You need to know perceptron. You need to know all these things. Learn something. So all these things will make a change. And then tell me, my deep learning here is got this one different than the people use. This one, nobody said that. I use custom CNN and Oompa Loompa again. That Oompa Loompa happens like hell, like since 2019, 2021. What is custom CNN? Basically, he doesn't know. And if I happen to read the same thing in the other paper, the exact same thing happens again. So my question is, if you cannot do these buzzwords and play around all the time, please learn things right? Please learn things right. And also the data sentiments. Data sentiments in medical imaging, very important. It is not a character recognition. It is not something logo detects and I do something. No, you can't do that. And the other thing is medical imaging, images are complex by nature. You look after something, but you catch something because of the diff feature. Diff features giving you distinct features. But you don't look all distinct features. You look only problematic features. That means you basically should go with the clinical procedure. I'm looking at ribs, Casey, not the heart side, just the ribs. Can deep learning gives me just the ribs by sending one whole full image of the chest X-ray? No, it gives me everything, all distinct features. But I'm looking at ribs, Casey. Can you give me that? That's what the clinical procedure is about. So if you deny clinical procedure and you just happen to use all these kind of fancy deep learning networks we got, They will come. I don't know what is in there, but I got 99%. I beat everybody. But do you think now clinical procedure is there? Do you think the clinical experts will take those into account? Because it's the black box. I'm not going to believe, right? So as a clinical expert, I don't believe. I'm not gonna approve this one for commercial purpose, because we will take care of humans. At the same time, what I hate from early career research scientists is, don't put your name of the model without changing anything. COVID-19 net, oompa loompa. Basically, he does nothing. If you want to say net, your whole architecture should be entirely new. Can anybody tell me Inception net is different than Google net? Yes. Can anybody tell me the other net is different than other net? Yes. So if you come up with the complete new architecture, then put the name net. Don't give me a name COVID-19 net. Come on, what do you want to do? You want to make people fool? We already are fool, by the way. We fool like a hell. You want to make fool again? That part we have to take care. Supervisors need to take care of all these buzzwords in addition to those buzzwords in the pool. Please take care of this net. I hate this net in the title. They do nothing, just put the net again.
Yes.
It's not the fish net, so you're gonna have those fishing. It is something that you are going to tell, and once published, it is published forever. Do you want to put your heads up in front of your kids? Do that, please.
Thank you, Professor Casey, for your nice lecture. We are all really.
Hi, Casey.
Yeah.
Thank you.
Hi, Casey. How are you doing?
Good.
Yeah, I'm just curious. I'm just wondering, like, during the lockdown period, we have seen various forecasting models, some coming from MIT, some coming from Harvard. And all those models were proved wrong because the government tried to do lockdown based on the prior data. And why do you think that, the data analysis or the forecasting was wrong in that case?
Let me tell you something, probably you have or you have not. I published one paper, COVID-19 prediction models and unexploited data. That paper tells the story of garbage in, garbage out. And people dislike it because I'm honest. I don't want to be big, just telling some different story and we don't get the actual value. All these predictions will give you numbers. That's what the tools are. Doesn't mean that these predictions should be exactly what it's going to be. And these predictions are way far from what the actual values were. That's why we had a problem of media. Medias, they didn't have intention to escalate the problem, but we forget to mention these prediction tools and techniques are limited to education and training. That's the part we forget. Media's taking those numbers into account. By April 2022, we're gonna have 300,000 cases more, which is not right, and it was not. And I'm gonna tell you something. No statistical models today will tell you when are you going to die and what time. In healthcare, social factors play a lot. If your healthcare, public healthcare, and all these infectious disease outbreaks come into play, social factors play a lot than just the ideal setting of stochastic mathematical models, where you just tune the parameters and predict something, it's going to be fine. When social factors come into play, you basically do garbage in, garbage out. All tools will give you a number at the end. That number doesn't mean that I'm going to die tomorrow. Who can tell me I'm going to die tomorrow? Nobody. That means our prediction models are just the models. This is the estimation. We forget to mention people that all these models are limited to education and training. First thing. Second thing, we don't take social factors into account. You stay 1 year at home. That means your salary should go down depending on the state government. When the salary is going down, you don't have money to buy protein bars. You look after your kids and everything. When your protein bar is down, you have immune system going down to who is going to take care of this one? So prediction model is this basically. I don't want to say being a predictive modeling scientist. I don't want to say all these things, but if I would have known Bitcoin share, which was $4,000 per share in March 2020, it is now 40K, 40,000. If I would have known that, I would be richer than Elon Musk today. That means no statistical model will tell you when you are going to die. It is apparently vivid clear for public healthcare because we don't take any social factors into account. And we also say that we are so good. Do you think now people will be convinced the way we do work? No, we make people fool. 1 million paper published. That's why my new paper is going to come up soon, saying that COVID-19 imaging tools, how big data is big data? Tell me. That's the question. Basically, the paper is in the line. Thank you. You got me right.
Yeah.
Yes,
Thank you.
absolutely correct.
Thanks, Case.
Yeah,
And
Kunshi,
that-
yeah.
Yeah, and
Kaushik.
that's the reason, financial forecasting is so hard. Otherwise, we could have just predicted the stock markets and everything, and we would be billionaires by now.
Thank you, Kasi.
Thank you very much, Casey, for your
Thank you.
such talk.
Everyone for joining. And we have another session, last session. Sunita Madam is waiting for us.
Thank you.
Thank you very
Thank
much.
you.
So I will have to stop this here.
Yes. Thank you.
Good, I did.
Thanks,
And
Casey. Thanks.
there are some
Thank you.
questions.
Hope to see you soon in summer. Yes.
you.
Oh. This is for you, Casey.
Come on. I'm not a big fan of these certificates, but again, thank you.
Yeah. Okay.
All right, good.
It's online.
I'll leave. Thank you.
Thank you. Bye.